Hey guys, today we're going to do polynomial functions and their graphs, which is section 3.2 in your book. So determining whether or not it's a polynomial function, you basically want to look at a couple things. So notice these are all whole number degrees, right? X squared, x to the fifth. So we've got a polynomial function with a degree of 5. Again here, even if you distribute all of this, it's still all those whole number exponents. Remember, square root, power over root, is 1/2. And that's what makes it's not an integer, so this is not a polynomial function. Here, that x squared, it winds up, it's in the denominator, so it's an x to the negative second. Again, we need non-negative. So understand you don't want any negatives, you don't want any fractional, you want those whole number integer exponents for polynomials. So let's talk about graphing a little bit. So from looking at a polynomial, you can actually determine what they call end behavior with something called the leading coefficient test. So you look at your leading coefficient, and you determine is it positive or negative. And you also look at your degree and classify it as even or odd. So if it's even, you want to think, the best way I have for you to think of is think of parabolas. Okay, remember a parabola is even, it's an x squared, right? It's even. Either the ends both face up, if your leading coefficient is positive, or the ends both face down. So notice here, rise to the left, rise to the right, up, up, or down, down. Okay, so evens, I want you to think of parabolas. And you can kind of apply all the wiggles in between. We'll talk about those. But we're just talking about end behavior here. And if you have a good concept of parabolas, that end behavior should fall right into place. Odds, let's think of the graph for x cubed, which is actually that S shape. If it's positive, we're going to be heading up, right? So down to the left, up to the right. Or if it's negative, we're going to be heading down, right? Start high and low. So we're heading up, we're heading down. So that's your positive and that's your negative coefficients. So let's actually see this going on. So those are the graphs that I think, if you just understand those graphs, you'll have a good concept of end behavior. So the first one. So our leading coefficient is 1, which is positive. And then our degree is 4, which is even. So positive and even, again, even we're thinking of parabolas, right? X squared. So you think of parabola, positive, both are going to head up. So it rises to the right and the left. Rises to the right, rises to right and left. Let's look at the next one. Now you might be looking at this and saying, ugh, alright, I have to FOIL this all out. This looks terrible. But you really don't, because all you need is the leading coefficient. So you know to, even if you did this, x times x is x squared. That's going to be your highest one here. Times 2x cubed, you're going to wind up with a 2x to the fifth, right? 2x to the fifth out front. And you know 2 is positive, so your leading coefficient leading coefficient is 2, which is positive. And your degree is going to be 5, which is odd. So remember odd, positive, you want to work your way up, right? We want to head up. Right, so if you remember that, to the left, it should fall, to the right it should rise. So decreases to the left, increases to the right. And you can write that if you want. Decrease to the left, rise to the right, if you want to write out the words. So understand what's happening with the end behavior of your graph. Here it says the polynomial function, blah, 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 models the ratio of students to computers in U.S. public school X years after 1980. Use end behavior to determine whether this function would be an appropriate model. Well into the 21st century. Explain your answer. So let's talk about end behavior. Our leading coefficient is negative. And our degree is odd. So again, this is just end behavior is all we care. This isn't what the actual graph looks like. But we want to negative, we want to start high and end low. Right, with that odd. So understand what this is saying. X years after 1980, notice where my graph's going. How can you have a negative computer ratio? Because this is going to keep going and going and going. So even if my graph is off, it's still going down for infinity. Okay, so eventually we're going to be getting into negatives. So no, you can't have, that's a C, can't have a negative computer ratio. And that's what this is saying, right? X years after 1980, we're going to start getting into the negatives. Next one, finding zeros. These are your x-intercepts. So zeros are your x-intercepts, which means you want your y to be 0. So we're here. When I see 4 terms, that tells me factor by grouping. So what do we got here? These two, we'll pair them up, we'll take out x squared. These two, we'll pair them up, we'll take out a -4, so we're left with x plus 2. And now we have that common factor, so we're going to pull out an x plus 2. If we pull out x plus 2, oh, sorry, I forgot my 0. If I pull out an x plus 2, I'm left with x squared. If I pull out an x plus 2, I'm left with 4. And x squared minus 4 does simplify down further, so we're going to leave this as x plus 2. And remember, this is difference of squares, x plus 2, x minus 2. So remember, x plus 2 can equal 0. X equals -2. Or x minus 2 can equal 0. X equals 2. So there's our two answers, plus or minus 2. All right, my next one. Find all the zeros. I'm going to go ahead. Again, zeros are x-intercepts. So let's factor out x squared. X squared minus 4. And again, difference of squares, x plus 2, x minus 2. So it looks like we have x squared equals 0, so x equals 0 is one of my answers. X plus 2 equals 0, x equals -2, and x equals +2. We don't have to do them all out. All right. Next one. So I do want to talk about multiplicity. Notice I wound up with x plus 2 twice here. So multiplicity is the number of times a 0 occurs. And that actually tells you what happens at that point. So notice -2 happened twice. X plus 2 equals 0, x equals -2. That happened twice. So my multiplicity would have been 2, which is even, which means my graph is going to bounce at that point. So what you would see at -2, let's say my graph was coming towards that -2. Once it hit, it would bounce and go the other way. Okay. Notice here, 2. 2 is only happens once. Only happens once, so its multiplicity was 1. What that would look like we'll just keep this on the same graph. We're going to make this one look bad. Multiplicity was odd, it actually crosses through at that point. Okay, so it's actually going to cross through. All right, so let's work with this here. So this one wants us to get our zeros. So it looks like x plus 1/2 can equal 0. So x equals negative 1/2. And our multiplicity will be twice. And then x minus 5 can equal 0. X equals 5. And our multiplicity is 3 times. So notice what's going to happen here. So it says state whether it crosses or basically bounces, touches the x-axis and turns around. So even, right, this is going to be a bounce. Right, it's going to hit it and go the other direction. And odd, this is going to cross. All right, that's going to cross that x-axis. Moving on. Intermediate value theorem just tells you if you're going to have a real, at least one real root between some solutions, okay, between some solutions. And how do you tell that it has occurred? Understand if you plug in these two numbers and one of them results in a negative y value and one of them results in a positive y value, you know they're going to cross the x-axis, right? Somewhere between them, there is a solution that crosses the x-axis. So let's plug them in and check. So we've got 3, negative 3 cubed, 10 times negative 3 plus 9. And if you do all of that out, you wind up getting negative 42. Let's plug in negative 2. So we've got 3 times negative 2 cubed, 10 times negative 2 plus 9. All said and done, you get 5. So notice this is negative y value, this is a positive y value. They're going to cross that x-axis somewhere between 2 and negative 3. Okay, somewhere between 2 and negative 3, you're going to cross that x-axis. So this is steps. This is steps if you're trying to graph. How do you graph? What do you need to find? So let's go ahead and apply it. So first thing we need to do, step one. Step one is determine your end behavior. So my leading coefficient is positive, and the degree is odd. So we're thinking positive, odd, something like that, right? Starts down, ends up. So get that in mind. X-intercepts, that was step 2. X-intercepts means your y is 0. I'm going to go ahead and factor this side while I'm at it. I factored out an x squared, so I know I'm going to wind up with x equals 0 and x equals 3. Now here your multiplicity is 2. Right? This actually happens twice. So you know here we're going to have a bounce. This one only happens once. Your multiplicity is 1, so we're going to cross at 3. So just kind of seeing what's going to happen with your graph. Next one, y-intercept. Let's see where we cross our y-axis, which means our x should be 0. So 0 cubed, 3 times 0 squared, 0 minus 0, you're going to cross that y as 0. Step 4 is we're actually going to find out if we have symmetry to the y-axis or symmetry to the x-axis. So if you look back here, we're going to run out of time. I'm probably going to pick this back up. Y-axis, if you plug in negative x, you should get the same function. Origin, if you plug in negative x, you should get the opposite of your function. So let's plug it in. Negative x cubed minus 3 times negative x squared. And we get negative x cubed minus 3x squared. So we get the same function, which means we're going to have symmetry